In this problem, we are going to work to understand the relationship between force on a bar, its spring constant, and the displacement or deformation of the bar. So we have given here a spring constant for a bar under axial loading of 138 kilonewtons per millimeter. So we know that the K will be 138 kilonewtons per millimeter, sorry. And we're asked what would the displacement be in micrometers for a load of 3 kilonewtons. I guess there's a typo there. So we have this idea that the K is force per displacement, like we see here, and we're being asked what is the displacement, and we're given over here a load which is 3 kilonewtons. So without even doing any physics-based calculations, we can get an idea of how the units might guide the answer to this problem. So we have a force given, and we're being asked for displacement, so we don't have that, but that's what we want. And we have a value, which is a spring constant force per displacement. So it may seem like we are shortcutting the physics a little bit, but we could just think in terms of force divided by this quantity here. So this quantity, 3 kilonewtons, divided by the 138 kilonewtons per millimeter. Write it out like that. Cross out the forces. And what are we going to be left with? Well, we're 1 over 1 over displacement, so we're just left with a displacement. If we use what we've been talking about, though, with the relationship given by Hooke's law, so force equals K delta. So we're going to use this variable a lot in the class. And we rearrange things, we get that delta is equal to force over K, and we can plug in the 3 kilonewtons and the 138 kilonewtons per millimeter. And what are we going to get? We're going to get a displacement. This displacement is 0.0217, so 3 divided by 138, right? So, that's a couple percent. That looks about right. But we have these units in millimeters. Now, the problem is asking, or I'm asking, for us to give the displacement in terms of micrometers or micrometers. And that is going to be done by using the conversion factor. So 1,000 micrometers or micrometers or microns are equal to 1 millimeter. So again, we can use the dimension or cancel the dimensions here, and we get the resulting 21.7 microns or micrometers. Right? So that's how we do this problem. You can stop here if you like, but once again, I thought maybe I'll just show us how to do it in Python. So where are, yes, right here. Okay, so here we are in Google Drive. We're going to create a collab, and first thing we'll do when it comes up is do an import numpy as np, and then we will, out of habit, go ahead and write another one. So we were given a force of 3 kilonewtons. So in this case, I'm going to just do 3 times 1,000, and that's going to mean that I'm in newtons. And then I've been given and we don't have to, get these units like this. We could have left it in kilonewtons because this is a value of 138 kilonewtons per millimeter. So we can do, if we want, though, we can go ahead and convert things. So that would be now in newtons, and per millimeter. Maybe not the best units, but we'll go ahead and leave it, I guess, for now. Okay, so there are multiple ways to do this, but it's very important to keep track of the units. So now the displacement, we'll call it delta, is going to be equal to force divided by K, like that. And that will give us the units in millimeters. Now, there are multiple ways to kind of get this conversion. but we can do delta equals delta uh, times 1,000. Whoops, and it even knows that's going to give us micrometers now, like that, or microns, or microns or micrometers, right? Just to keep track of the units. And then we can print delta, or maybe lowercase. That's fine, doesn't matter. Like this, and one decimal place will be fine. And what are the units? Well, these should be in microns, just like that. So we hit Control Enter, and voila, we see that it's 21.7 micrometers, just like we got on the previous slide. Thank you.